In this video, we're going to talk about number 207 course schedule and 210 course schedule 2 on LeetCode. Let's look at the question first. There are a total of num courses you have to take, labeled from 0 to num courses -1. Some courses may have prerequisites. For example, to take course 0, you have to take course 1 first, which is expressed as a pair 0, 1. Given the total number of courses and the list of prerequisite pairs, is it possible for you to finish all courses? Based on the question description, we know the output is going to be a Boolean. So it's either going to be true or false. And the description for course schedule 2 is very similar to this one, except for the output. We want an ordering of the courses you want to take. So let's look at some examples first. In the first example, so there are 2 courses, and the prerequisites contains 1, 0, so we want to take 0 first and then take 1. And the true order is 0, 1. And this is a valid input because we can generate this pair, this order right here. And in the second example, there are 2 courses. We want to take 0 first and then take 1. And we want to take 1 first and then take 0. The two pairs violate each other, so it's a false. And we don't have any valid ordering for these 2 courses. And in the third example, we have 4 courses. And we have this order. We want to take 0 first and then 1. 0 and then 1. And we want to take 0 first and then 2. 0 first and then 2. And we want to take 1 first and then 3. And we want to take 2 first and then 3. So look at this. So after we took 0, course 0, we can take 1 and 2 in whatever order. And after we're done with 1 and 2, we can take course 3. So we can see there's a degree here. 0 is at the very first degree 0, and course 1 and course 2 are at degree 1, and the course 3 is at degree 2. And it's a valid input. We can take them in order, in either this one or this one. Yeah. So now we have a very clear understanding of both of the questions. We can dive deeper into the solution. So here we're gonna use a topological sort and use the third example to run our topological sort. So first, we want to construct a graph using the pairs provided. Each pair gives us information about an edge. The first element is the target node on the edge, and the second element is the source node on the edge. The source comes first and the target comes next. So for the first pair, we can generate a node 0 and having an edge pointing to node 1. In the second pair, we want to generate the node 0, but we already have a node 0 here, so we can just having an edge pointing to node 2. And then for this pair, for the third pair, we want to generate the node 3 and having an edge from node 1 to node 3. Similar for this one, for 3-2 pair, we want to have an edge between node 2 and node 3. But we already have a node 3 here, so we're just having an edge pointing to node 3 from 2. And this is our final edge. And we just want to run a topological sort on this graph using a stack. You can also use the stat or use a queue. Either one works. So we want to find the starting point first. Starting point. And in this case, it's node 0 because it doesn't have any incoming edge. And we can start popping from our stack. until it is empty. So we pop 0 first, and let's look at the edges from 0 to other nodes. We can first look at this one, and after we remove this edge, node 1 becomes a new starting point. So we add node 1 here. After we remove this edge, node 2 also becomes a starting point. So we can add 2 into our stack. So the order of 1 and 2 doesn't really matter because they're at the same degree. And then we pop out 2 and look at this edge. And we remove this edge. And we don't have any new starting point at this point. And we keep popping things from our stack. Pop node 1 out. And let's look at this edge. And remove this edge. Node 3 becomes a new starting point. So we add node 3 here and pop node 3 out. There's no outgoing arrow from node 3, so we're done with this. Our stack is empty. So the answer must be true, because we have popped all the courses we have seen in a certain order. So this is a valid input. And for course schedule 2, we want to get the exact ordering of the courses, and the order of how we pop things out from the stack is going to be the answer. Let's go back. Remember, we popped out 0 first. It is our initial starting point. So 0. And then we popped out 2 because we added 2 and 1 together. And the 2 is on top of 1. So 2 goes out first. Because stack is a first in, last out data structure. So we pop out 2. And then we pop out 1. And then we pop out 3. So this is a valid answer. If we have pushed in 2 and 1 in reverse order, so if 2 goes in first and the 1 goes in later, it's still going to be the same. So it's going to be 0, and then 1, and then 2, and then 3. This is also a valid answer. See here. And next, we can consider some edge cases. It's possible that the given input doesn't provide a starting point for us. For example, in this example, we construct the graph first. So 1 pointing to 0 and 0 pointing to 1. In this case, we can't find the starting node because both of the nodes have an incoming edge and an outgoing edge. So in this way, our stack is always going to be empty. So that's invalid because to begin with, you have to have something in your stack. So this is not valid, even though you have a starting point. So let's say if our graph looks like this. You have a starting point as 1, and you pop out 1. So the new graph looks like this, which is the same as this. At this point, you can't really do anything because there's no starting node, and you got stuck. So this is also false. And another corner case is nodes are not connected. So it's possible that we have a graph like this. So you have to take course 2 before course 1. You have to take course 4 before course 3. But this group of courses and this group of courses don't have any connection between each other. So to begin with, our stack should have 2 nodes inside. It doesn't change, it doesn't affect if we generate true or false, because even though they're not connected, it's still possible to take all the courses in a valid order. So you can just have them in your stack and run the normal topological sort.